Cybersecurity refers to the protection of digital devices, networks, and systems from unauthorized access, theft, and damage. It has become increasingly important in recent years as the world has become more reliant on technology and the internet for both personal and professional activities. Cyber attacks can range from minor nuisances, such as spam and phishing emails, to major threats, such as data breaches and cyber warfare. The first line of defense against cyber attacks is a strong password policy. Passwords should be long and complex, and it is important to use different passwords for different accounts to prevent a single compromise from affecting multiple systems. Additionally, two-factor authentication, which requires a second form of identification beyond just a password, can provide an extra layer of security. Another important aspect of cybersecurity is network security. This involves protecting networks from unauthorized access, and ensuring that data transmitted over the network is secure. Network security measures can include firewalls, virtual private networks, VPNs, and encryption. Software security is also a key component of cybersecurity. Software vulnerabilities can be exploited by attackers to gain unauthorized access to systems and steal data. To minimize these risks, software should be regularly updated and patched, and security measures such as antivirus software and intrusion detection systems should be implemented. Another important aspect of cybersecurity is data security. This involves protecting sensitive data from unauthorized access, theft, and damage. Data security measures can include encryption, access control, and data backup and recovery procedures. Another aspect of cybersecurity is social engineering, which is the use of deception to manipulate individuals into divulging confidential information. This can take the form of phishing emails, which trick individuals into revealing their login credentials, or baiting, where attackers leave a physical item such as a USB drive in a location, hoping that someone will pick it up and insert it into a computer, thereby compromising the system. To mitigate the risks of social engineering, organizations should educate their employees on the dangers of these attacks and implement security awareness training programs. Additionally, disaster recovery and business continuity planning are important components of cybersecurity. These plans outline procedures for responding to cyber attacks and ensuring that business operations can continue despite a breach. However, despite these measures, cyber attacks are still a significant threat. The cost of cybercrime is estimated to be in the trillions of dollars annually, and the number of attacks continues to increase. To stay ahead of these threats, organizations must continuously evaluate and improve their cybersecurity measures. This may involve investing in new technologies, such as artificial intelligence and machine learning, to help detect and prevent attacks. In conclusion, cybersecurity is the protection of digital devices, networks, and systems from unauthorized access, theft, and damage. It is a complex and ever-evolving field, with new threats emerging regularly. To minimize the risks of cyber attacks, organizations must implement a comprehensive security strategy that includes strong password policies, network security measures, software security, data security, social engineering awareness, and disaster recovery and business continuity planning. Additionally, they must continuously evaluate and improve their cybersecurity measures to stay ahead of evolving threats. Edge computing refers to a computing architecture where data is processed and analyzed at the edge of the network, near the source of the data, instead of being transmitted to centralized data centers or cloud servers. This approach can result in faster and more efficient processing of data, as well as reduced latency and bandwidth usage. In traditional computing, data generated by devices such as sensors, cameras, and machines is transmitted to centralized data centers or cloud servers for processing. However, this approach can result in bottlenecks and delays, as the data must first be transmitted over the network and then processed. Edge computing solves this problem by processing data at the edge of the network, near the source of the data. This reduces the amount of data that must be transmitted, resulting in faster processing times and lower latency. Additionally, by processing data at the edge, edge computing can help to reduce bandwidth usage, as only the relevant data is transmitted to centralized data centers or cloud servers. One of the key benefits of edge computing is its ability to process data in real time. This is particularly important for applications such as autonomous vehicles, where quick decision-making is crucial. By processing data at the edge, edge computing can help to ensure that decisions are made quickly and accurately, without the need for data to be transmitted and processed in centralized data centers or cloud servers. Another benefit of edge computing is its ability to support low-latency, high-bandwidth applications. For example, virtual and augmented reality applications require low latency and high bandwidth to provide a seamless and responsive experience. By processing data at the edge, edge computing can help to ensure that these applications run smoothly, without the need for data to be transmitted and processed in centralized data centers or cloud servers. Edge computing also offers increased security and privacy, as data can be processed and analyzed at the edge, without the need for it to be transmitted to centralized data centers or cloud servers. This can help to reduce the risk of data breaches, as the data is not transmitted over the network, and it can also help to protect sensitive data, as it is not stored in centralized data centers or cloud servers. Edge computing is also well suited to supporting applications in remote or disconnected locations, such as in industrial or agricultural environments, where connectivity to centralized data centers or cloud servers is limited. By processing data at the edge, edge computing can help to ensure that these applications can continue to run, even in the absence of a network connection. However, edge computing also presents some challenges, such as the need for robust and reliable hardware and software, as well as the need for effective data management and analysis techniques. Additionally, as edge computing is still a relatively new field, there is a shortage of skilled professionals with the necessary knowledge and experience to implement and manage edge computing systems. In conclusion, edge computing is a computing architecture that enables data to be processed and analyzed at the edge of the network, near the source of the data, instead of being transmitted to centralized data centers or cloud servers. Edge computing offers numerous benefits, including faster processing times, lower latency and bandwidth usage, real-time processing, support for low latency, high bandwidth applications, increased security and privacy, and the ability to support applications in remote or disconnected locations. However, edge computing also presents some challenges, such as the need for robust and reliable hardware and software, as well as effective data management and analysis techniques, and a shortage of skilled professionals. Robotic Process Automation (RPA) is a technology that enables organizations to automate repetitive, routine tasks that are typically performed by humans. RPA uses software robots, or bots, to automate these tasks, freeing up employees to focus on more strategic and valuable work. RPA operates by using software bots to interact with existing systems and applications in the same way that a human would. The bots are programmed with business rules and processes, allowing them to perform tasks such as data entry, form filling, and document management. RPA is designed to work alongside existing IT systems and does not require any changes to the underlying systems or applications. One of the key benefits of RPA is increased efficiency. By automating repetitive and routine tasks, RPA can help organizations to reduce errors and improve accuracy, as well as reduce processing times. This can lead to increased productivity and cost savings, as well as improved customer satisfaction. Another benefit of RPA is increased agility. RPA can help organizations to respond quickly to changing business needs, as bots can be quickly reconfigured to perform different tasks. Additionally, RPA can help organizations to scale quickly, as new bots can be added as needed, without the need for additional human resources. RPA also offers improved compliance and security, as bots are programmed to follow specific business rules and processes. This can help to reduce the risk of errors and ensure that sensitive data is handled in accordance with established policies and procedures. RPA also has the potential to improve employee engagement and job satisfaction, as it enables employees to focus on more meaningful and strategic work, rather than performing repetitive and routine tasks. However, RPA is not a one-size-fits-all solution, and there are some limitations and challenges that organizations need to be aware of. For example, RPA may not be suitable for complex tasks that require human judgment and decision-making. Additionally, RPA may not be able to fully automate processes that require manual intervention or that are subject to frequent change. Another challenge with RPA is the need for skilled professionals to implement and manage RPA systems. Organizations need to ensure that they have the necessary expertise in-house, or that they engage with a trusted RPA partner, in order to fully realize the benefits of RPA. Finally, organizations need to carefully manage the transition from manual to automated processes, to ensure that they are able to fully realize the benefits of RPA. This may involve training employees, establishing new processes and procedures, and ensuring that the RPA solution is integrated with existing systems and applications. In conclusion, RPA is a technology that enables organizations to automate repetitive and routine tasks, freeing up employees to focus on more strategic and valuable work. RPA offers numerous benefits, including increased efficiency, increased agility, improved compliance and security, and improved employee engagement and job satisfaction. However, RPA is not a one-size-fits-all solution, and there are some limitations and challenges that organizations need to be aware of, such as the need for skilled professionals to implement and manage RPA systems, and the need to carefully manage the transition from manual to automated processes. Digital trust refers to the confidence people have in the security, privacy, and reliability of the digital systems and technologies they use. It involves ensuring that sensitive information, such as personal data and financial transactions, is protected against unauthorized access, manipulation, or theft. With the increasing reliance on technology in all aspects of life, digital trust has become a critical issue. This is because the vast amounts of data generated and stored online are highly attractive to malicious actors, who can use it for identity theft, fraud, and other malicious activities. To build and maintain digital trust, organizations must adopt a multi-layered approach that involves implementing strong security measures, such as encryption and firewalls, and regularly monitoring and updating them to stay ahead of evolving threats. In addition to technical measures, organizations must also prioritize transparency and accountability in their data handling practices. This includes being clear about what data they collect, how they use it, and with whom they share it. They should also provide clear and easy to understand privacy policies and have a process in place for responding to and reporting data breaches. Consumers also have a role to play in maintaining digital trust. This includes being cautious about the information they share online and being vigilant for signs of fraud or identity theft. It also involves being aware of the privacy policies and security measures in place for the digital services and technologies they use. Building digital trust is a shared responsibility between organizations and consumers, and it requires ongoing effort and collaboration. As the digital landscape continues to evolve and new technologies are developed, it will become increasingly important for organizations to prioritize digital trust and for consumers to be aware of the risks and how to protect themselves. However, despite the best efforts of organizations and consumers, digital trust can still be compromised. When this happens, the consequences can be significant, with loss of personal information, financial losses, and damage to reputation. This highlights the importance of having effective legal frameworks in place to protect individuals and organizations and to hold those responsible for data breaches accountable. In conclusion, digital trust refers to the confidence people have in the security, privacy, and reliability of digital systems and technologies. It involves implementing strong security measures, prioritizing transparency and accountability in data handling practices, and being cautious and informed as consumers. Building and maintaining digital trust is a shared responsibility that requires ongoing effort and collaboration, and its importance will only continue to grow as technology continues to evolve. However, despite best efforts, digital trust can still be compromised, emphasizing the importance of having effective legal frameworks in place to protect individuals and organizations. 3D printing is a process of creating a physical object from a digital design using a printer that builds it layer by layer. The process starts with creating a digital model of the object using computer-aided design (CAD) software. This model is then divided into thousands of thin horizontal layers, and a 3D printer uses this information to build the object layer by layer, starting from the bottom and working its way up. 3D printing has been around for over 30 years and has evolved from a tool for rapid prototyping in the manufacturing industry to a technology with applications in many fields, including healthcare, architecture, fashion, and aerospace. In healthcare, for example, 3D printing is used to create custom prosthetics, implants, and even human organs for transplantation. In architecture, 3D printing is used to create scale models of buildings, and in fashion, it is used to create unique and intricate designs that would be difficult or impossible to produce with traditional manufacturing methods. One of the key benefits of 3D printing is that it enables the production of complex and customized objects that would be difficult or impossible to manufacture using traditional methods. For example, a patient in need of a prosthetic limb can have one designed and printed that fits perfectly and is customized to their specific needs. This level of customization was not possible with traditional manufacturing methods, which often relied on mass-produced parts that had to be adapted to fit the individual. 3D printing also has the potential to revolutionize supply chain and logistics. With 3D printing, products can be manufactured on demand, reducing the need for large inventories and minimizing waste. This could lead to a more sustainable and efficient supply chain, with products being manufactured only when they are needed and without the need for long-distance shipping. Another benefit of 3D printing is that it is relatively fast and cost-effective compared to traditional manufacturing methods. The process of printing an object can take anywhere from a few hours to several days, depending on the size and complexity of the object. Additionally, 3D printing eliminates many of the costs associated with traditional manufacturing methods, such as tooling and setup costs, allowing for the production of small quantities of parts at a lower cost. However, there are also some challenges associated with 3D printing. One of the main challenges is that the technology is still in its early stages and has not yet reached its full potential. The materials used in 3D printing are also limited, and while they have improved significantly in recent years, they still lack the durability and strength of traditional materials such as metal and plastic. Another challenge is that 3D printing requires a high level of skill and expertise to operate, and the process is still not as user-friendly as traditional manufacturing methods. This is a barrier to wider adoption of the technology, particularly for small businesses and individuals who may not have the resources to invest in the necessary equipment and training. In conclusion, 3D printing is a rapidly evolving technology with the potential to revolutionize the way products are manufactured and distributed. It offers the benefits of increased customization, speed, and cost-effectiveness, but there are also challenges associated with the technology, including limited materials, lack of user-friendliness, and a need for specialized skills and expertise. As the technology continues to evolve, it will be interesting to see how it will impact various industries and the way we live and work. 5G is the next generation of mobile telecommunications technology that promises to bring significant improvements in speed, reliability, and coverage compared to 4G, the current generation. 5G networks are designed to support a much higher number of connected devices and provide low latency, high bandwidth communication for data-intensive applications such as virtual and augmented reality, the Internet of Things, IoT, and autonomous vehicles. 5G networks use a combination of new and existing frequency bands to support communication, including high-frequency millimeter wave, wave, bands, low-frequency sub-6 GHz bands, and mid-frequency bands. The use of these different frequency bands enables 5G networks to deliver high data rates, low latency, and wide coverage, making it possible for a variety of new and innovative applications. One of the main benefits of 5G is its increased speed. 5G networks are expected to deliver download speeds of up to 10 gigabits per second, GBps, which is several times faster than the fastest 4G networks. This increased speed will allow for new applications such as augmented reality and virtual reality, which require high bandwidth and low latency communication to provide a seamless user experience. Another benefit of 5G is its ability to support a much higher number of connected devices compared to 4G. With the rapid growth of IoT devices, 5G networks are designed to accommodate millions of devices, providing low latency, high-speed communication for a wide range of applications, such as smart homes, autonomous vehicles, and industrial automation. 5G also brings improvements in coverage and reliability compared to 4G. 5G networks use small cells and advanced antenna technology to provide wide coverage and reduce network congestion, leading to more reliable connections and improved network performance. The use of 5G networks will also lead to improvements in energy efficiency, as the increased spectral efficiency of 5G networks means that devices can communicate more data using less power. 5G networks are expected to play a major role in the development of new and innovative technologies, such as autonomous vehicles and the Internet of Things. Autonomous vehicles rely on real-time communication between the vehicle and the network to make decisions and navigate, and 5G networks are expected to provide the low latency and high-speed communication needed to support this technology. The Internet of Things, IoT, is also expected to benefit from 5G networks, as the increased speed and reliability of 5G networks will allow for real-time communication and control of a vast number of devices. For example, 5G networks could be used to control smart homes, where IoT devices such as thermostats, lights, and security systems are connected to the network and can be controlled remotely. However, there are also some challenges associated with 5G technology. One of the main challenges is the cost of deploying 5G networks, which is significantly higher than the cost of deploying 4G networks. This cost includes the cost of upgrading existing infrastructure, acquiring new spectrum, and developing new technology. Another challenge is the security of 5G networks, as the increased number of connected devices and the use of new frequency bands can make 5G networks more vulnerable to cyber attacks. There is also a concern about the potential health risks associated with the high-frequency wave bands used in 5G networks, as some studies have suggested that exposure to these frequencies could be harmful to human health. In conclusion, 5G is the next generation of mobile telecommunications technology that promises to bring significant improvements in speed, reliability, and coverage compared to 4G. 5G networks will play a key role in the development of new and innovative technologies, such as autonomous vehicles and the Internet of Things, and will provide the foundation for new applications and services that require high-speed, low-latency communication. However, the deployment of 5G networks also presents challenges, such as the cost of deployment, lack of standardization, and security concerns. It will be important for governments, industry, and consumers to work together to address these challenges and ensure the successful deployment of 5G networks. Artificial intelligence, AI, is the field of computer science concerned with building systems that can perform tasks that would normally require human intelligence, such as visual perception, speech recognition, and decision-making. Machine learning, milliliter, is a subset of AI that deals with the design and development of algorithms that can learn from and make predictions or decisions based on data. Milliliter algorithms are trained using large amounts of data, allowing them to make predictions or decisions without being explicitly programmed to do so. This enables milliliter systems to automatically improve and adapt over time, becoming more accurate and effective as they learn from more data. There are three main types of milliliter: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the algorithm is trained on labeled data, and uses this training data to make predictions about new, unseen data. In unsupervised learning, the algorithm is not given any labeled data and instead tries to identify patterns and relationships in the data on its own. Reinforcement learning is a type of milliliter where the algorithm learns from the outcomes of its actions and receives rewards or punishments to guide its decision-making. Milliliter has a wide range of applications, including image and speech recognition, natural language processing, fraud detection, and recommendation systems. It is being used in many industries, such as finance, healthcare, retail, and transportation, to make more informed decisions, improve operational efficiency, and enhance customer experiences. One of the biggest advantages of milliliter is its ability to scale and improve over time. Unlike traditional rule-based systems, milliliter algorithms can continuously learn and adapt, becoming more accurate and effective as they are exposed to more data. This ability to continuously improve is what sets milliliter apart from traditional programming, where the system must be updated manually to improve performance. Another advantage of milliliter is its ability to process large amounts of complex data, making it possible to identify patterns and relationships that would be difficult or impossible for a human to see. This can be particularly useful in areas such as healthcare, where milliliter algorithms can be used to analyze medical images and help diagnose diseases. However, milliliter also has some limitations and challenges that need to be considered. For example, milliliter algorithms are only as good as the data they are trained on, and they can be biased if the training data is biased. This can lead to incorrect predictions or decisions if the data is not representative of the real world. Another challenge with milliliter is interpretability. Unlike traditional rule-based systems, it can be difficult to understand how an milliliter algorithm arrived at a particular decision or prediction, which can make it difficult to trust the results. Finally, milliliter requires a significant investment in terms of data, computing power, and expertise, and it can be difficult for organizations to get started with milliliter without access to these resources. In conclusion, AI and milliliter are fields of computer science concerned with building systems that can perform tasks that would normally require human intelligence. Milliliter algorithms are trained on large amounts of data, allowing them to make predictions or decisions without being explicitly programmed to do so. Milliliter has a wide range of applications and offers several advantages, including its ability to scale and improve over time, and its ability to process large amounts of complex data. However, milliliter also has some limitations and challenges, such as the risk of bias, interpretability, and the need for significant investment in data, computing power, and expertise. Extended reality, XR, is a catch-all term used to describe a range of technologies that create immersive digital experiences. It includes virtual reality, VR, augmented reality, AR, and mixed reality, MR. VR is a fully immersive digital environment that users can interact with. It is created using computer-generated graphics and requires the use of a headset, such as the Oculus Quest or HTC Vive, to experience. VR is often used for gaming, training simulations, and therapeutic applications. AR enhances the real-world environment with digital information, often displayed on a device such as a smartphone or tablet. AR can be used to display information, such as product details, in real time and in context, making it a useful tool for education, marketing, and commerce. MR is a hybrid of VR and AR, where digital information is integrated into the real-world environment in a way that allows the user to interact with both the real world and the digital information. Microsoft's HoloLens is an example of a MR device. XR has the potential to transform a wide range of industries, from gaming and entertainment to education, healthcare, and commerce. In education, for example, XR can be used to create immersive learning experiences that engage students and help them retain information more effectively. In healthcare, XR can be used for training and simulation, helping medical professionals improve their skills and prepare for complex procedures. One of the main benefits of XR is its ability to create highly immersive experiences that can engage and educate users in a way that is not possible with traditional forms of media. XR can also provide access to information and experiences that would otherwise be difficult or impossible to access, making it a useful tool for training and education. However, XR also presents some challenges and limitations. One of the biggest challenges is the high cost of hardware and software, which can make it difficult for individuals and organizations to adopt XR. Another challenge is the need for a high level of technical expertise to create and maintain XR experiences. Additionally, there are concerns around the long-term effects of using XR, such as eye strain, headaches, and disorientation. There is also a risk that XR could become addictive, leading to users spending excessive amounts of time in virtual environments. In conclusion, extended reality, XR, is a term used to describe a range of technologies that create immersive digital experiences. It includes virtual reality, VR, augmented reality, AR, and mixed reality, MR. XR has the potential to transform a wide range of industries, providing access to information and experiences that would otherwise be difficult or impossible to access. However, XR also presents some challenges and limitations, including the high cost of hardware and software, the need for technical expertise, and the potential for negative effects on users.